Om Swastiastu. Good morning, and before I start my presentation, let me introduce myself. My name is Tjokorda, and my student ID number is 22055311150. Here I will present Science of Engineering Materials about molecular weights of polymers and polymerization process. My reference is from Science of Engineering Materials books, volume 2, that written by Manas Chandra. Here is the table of contents of my presentation. First one, there is molecular weights of polymers. The second is definition of resin and plastics. The third is polymerization process. And the last one is the structural shapes of polymer molecule. Okay, first, molecular weights of polymers. In pure low molecular weight compounds, such as sucrose, all the molecules are of the same size and have identical molecular weights m. Such compounds are said to be monodisperse. In contrast, most polymers are polydisperse. That is, they consist of molecules of a range of size and molecular weight. Consider a sample of polydisperse polymers of total weights y, w, in which n equals total number of moles, and I equals number of moles of species I, comprising molecules of the same size. The tiny n I equals mole fraction of species I. The w I equals weight of species I, and the tiny wi equals weight fraction of species I. And the last one is the mi equals molecular weights of species I. Definitions of resins and plastics. Resins are vegetable-derived organic products with relatively high molecular weights, the most famous of which are resins and balsams, obtained from conifers. However, the term is now used much more broadly and somewhat loosely, to include man-made polymeric substances used in a variety of applications, such as in plastics, textiles, and paints. The term plastics is also used in classifying polymers and includes all polymers which are not considered to be elastomers or rubbers, and fibers which show neither the elastic properties of elastomers nor the high crystallinity and strength of fiber.
It involves many steps, but in this video we are going to see 5 steps. Step 1. Extraction of crude oil. Step 2. Refining of crude oil. Step 3. Production of ethene. Step 4. Polymerization of ethene to get polyethene. Step 5. Polyethene converts into plastic pellets to make wide range of plastic products. In the process of crude oil extraction, the pump, which mainly contain power shaft, cranks, walking beam, horse head, polished rod, extracts oil from the earth. Inside the earth, the pump has casing, valves, etc. This complete extraction process has maximum safety precautions because crude oil contains many flammable chemicals. The extracted crude oil is sent to the factory and transported in the form of cans. And the next step is refining the crude oil. The crude oil is sent through the preheater that boils the crude oil and sent to furnace. By the refinery process, we get resid, lubricant oil, diesel, kerosene, petrol, naphtha, LPG, etc. And naphtha is our main product in plastic production. They are collected in different sections. Ethene is the most important substance in making of plastic, and ethene is made from naphtha. To make ethene, naphtha is sent to naphtha cracking center. There, naphtha is heated up to 800 degrees centigrade by using steam crackers. In quenching process, naphtha is break down into hydrocarbons. Then it is compressed and refined. We get ethene, propylene, butadiene, petroleum ether, etc. By this process, we made our important product in plastic production, that is ethene. And the next step, ethene is converted into polyethylene by the process of polymerization. First, the ethene is compressed and cooled. Then it is now dense, almost like liquid. It is sent to the reaction chamber. In the reaction chamber, initiators are added. Initiators means a substance which start chain reaction. Then polymerization takes place. By this process, the ethene converted into polyethylene. The polyethylene sent to a chamber that adds antioxidants and stabilizers. Then the polyethylene is get into the extruder, which converts polyethylene into polyethylene strings. The polyethylene strings are passed through the grinder or pelletizer, which converts polyethylene strings to polyethylene pellets, means plastic pellets. These plastic pellets are sent to other factories. They melt the pellets and molded into a wide range of plastic products.
Polymerization processes. The processes of polymerization are divided into two groups known as step polymerization and chain polymerization. The step polymerization is occurred by stepwise reaction between functional groups of reactants. The reaction leads successfully from monomer to dimer, trimer, tetramer, pentamer, and so on until finally a polymer molecule with large dp is formed. For example, the N-mer plus monomer, it will be N plus N-mer, and the N-mer plus M-mer, it will be N plus M-mer. Chain or addition polymerization is processed by a mechanism distinctly different from step or condensation polymerization considered above. Chain polymerization involves three processes, namely chain initiation, chain propagation, and chain termination. A fourth process, chain transfer, may also be involved. It may be regarded as a combination of chain termination and chain initiation. Structural shape of polymers molecules. Polymers can be classified on the basis of structural shape of polymers molecules as linear, branch, or cross-linked. Schematic representation of these types of polymers are given in figure. Schematic representation of linear is A, branch is B and C, and cross-linked is D and E polymers. The branch points and junction points are indicated by heavy dots. Polymers for use as textile fibers are linear polymers. However, they must satisfy two additional requirements, namely high molecular weight and a permanent orientation of the molecule parallel to the fiber axis. It is essential that the molecule have a high degree of order and a strong secondary for subfermate orientation and crystallization. Okay, this is the end of my presentation. So that's why I will say thank you. Om Santi Santi Santi.